Today we're going to be reacting to using Minecraft as a web server.
You tired of good things? Have you ever built a website and thought, man, if only I could do 4 times the work to achieve a fraction of the
I'm sorry, I'm already pausing. I need to change the title real quick.
performance? Well, wish no more. Introducing the worst idea I've ever had, MCDB. Take a look at this website. It's a simple website made for the Minecraft community that allows players to show off their latest creations. Of course, the front end isn't half bad, but let's take a look at the back end. That's right, this website dedicated to Minecraft creations is in itself a Minecraft creation. Everything is stored and served directly from this world, including front-end source code, data tables, and even the files uploaded by users. This system is complete with its own query language, authentication,
This guy is goated,
and even
bro. He looks
security
goated.
protocols.
What?
So, how did
How?
I get here? And what the hell is wrong with me?
Bro, how much time would this be? I want to know how many hours this is taken. Wait, move cam?
All of the source code for this project can be found on my GitHub by following the link in the description. And while you're down there, please consider subscribing to this channel. This is my first video, and I'd love to stick around and keep making cool things like this. Now let's discuss my sins. This project started off as a joke between a friend and I. Well, I guess it never stopped being a joke. Either way, my only goal was to make a Minecraft server into a database. That was it. And to do that, I had to figure out how I was going to store data in a Minecraft server to begin with. I decided to take a look at modern data storage for ideas. When computers store data, they'll do so using 8-character strings made up of zeros and ones. These are called bytes. Bytes can be used to represent many things, including letters, numbers, and symbols. If a computer wanted to store a bit of text, let's say a message, that message would first be converted into a sequence of bytes, with each byte representing one character of the message. Later, when it wants to
I'm gonna be real, I don't understand binary, but he's explaining it well.
read that message, those bytes will be converted back into human-readable characters. Now, why are we talking about bytes? I thought this video was about Minecraft.
Yeah.
Well, it's because we can actually do this exact same thing in Minecraft using blocks. Let me explain. Instead of using zeros and ones, we can use wool blocks to construct bytes. We'll use white wool for 0 and black wool for 1. Now, I'm not afraid of a little bit of labor, but there's no way I'm going to sit around all day and construct bytes by hand. So instead, I wrote a server plugin to be able to write, read, and delete messages all from the command line. Now, what we
Wait, this guy made a photo editor in Minecraft?
got here is good, but it's far from finished.
Oh
See,
my
a proper
God.
database would be able to store multiple things at a time. Right now, we can only store one thing.
That's sick
We also
as
need
shit.
to organize our data in a way that we can properly target it later if we want to read a specific message or delete a specific message. Now, we could just keep writing bytes in a straight line and then set new data entries next to the old ones in a parallel sequence, but that's a little bit too ooga booga for me. I am almost better than that. Also, we've got villages nearby. We don't want to be the ones out here industrializing.
This guy's making bytes in Minecraft and he's going to ooga booga, brother.
Small town America.
Bruh.
Instead, I think we should take advantage of the Minecraft chunking system. A chunk is a Minecraft term used to describe a 16 by 16 block section of the world. Chunks are commonly used to measure long distances, but for our purposes, we can use this pattern to declare a grid system. For example, the chunk at the very center of the world can be referenced as 0, 0. That is, x equals 0 and z equals 0. The chunk directly east will be called 1, 0, and so on and so forth. When we want to add a new message, we can find the next available chunk and write our message there. Now, when we want to write to a chunk, instead of going in a straight line, we can start at the bottom of the chunk and start writing bytes from left to right. And when a layer gets filled, we can move up to the next layer and continue writing. This approach allows us to use vertical space while also organizing our messages in a way that makes sense. For example, if we have 4 messages and we want to read the third one,
Imagine you're in like a factions Minecraft server, right? And there's like a password. And then you see this and you're like, what the hell is this? Meanwhile, this guy can encrypt it to actual letters. Oh.
we know that message number 3 will be written inside of the chunk at 3, 0. Wow. Nice. This is really good. Except for the part where it's not at all. You see, this is completely useless. We can only use this database within the game itself. That's not going to fly. A proper database needs to be used by a website, an app. You know, we got things to do.
It
So we need to
gets
figure
more
out how we're going to set this up so we
complicated,
can
bro.
actually make use of the items we're storing in this database. Traditionally, when a website needs to access an outside source, like a server, they will operate on a system of requests and responses. The website, or more accurately, the client, will send a request to the server. It might say, "Hey, show me message number 3. The server would then respond with message number 3. When visualized, both requests and responses will look something like this. Both will be defined by 3 key properties. The first.
Imagine you build a company, right? And you go, yo, what web servers do you guys use? Cloudflare? Nah, I use Minecraft.
First property is called the method. At a basic level, the method is used to declare the intention of the request with a single word.
I don't even know if
For example, if the client sends a request using the put method, this means that the request is intended to put something into the server's database. The second key property is called the header. A header allows the sender of the request to give a heads up about the request. The sender may use the content length header to tell the receiver how large the request is, measured in bytes. If needed, a request can contain multiple headers. We'll get into headers a little bit more later, as they're going to become crucial for some of the more serious stuff we'll be doing. For now, just know that they exist. And finally, the third key property is called the body. This is where the actual meat of our request will go. In the case of our put requests, this is where the data we wish to add to the database will go. For stupidly simple applications, the client and the server can get away with communicating via plain text.
I'm gonna be real.
But for
I'm gonna be real, this is so interesting, but my brain can't like keep following this without getting bored.
Applications with even the slightest bit of
Am I
complexity,
cooked?
it's generally better to use JSON when transferring information. JSON is a simple and extremely common way to structure pieces of data. For example, if the client wants to add a message to the database, instead of simply sending plain text to the server, it can send a JSON object containing a message property.
Okay, I'm good now.
A JSON object can have multiple properties, allowing the client to include other useful information. It could include an author, a timestamp, or anything else that may come in handy. This is called the Hypertext Transfer Protocol, or HTTP, and it basically runs the plan.
Okay, I'm overcooking
now,
it.
Minecraft servers do not inherently accept HTTP requests. They operate on
my
a
bad.
different
Wait, let me go back to it. My bad. Let me put everything back. I'm sorry.
Include an author, a timestamp, or anything else that may come in handy. This is called the Hypertext Transfer Protocol, or HTTP, and it basically runs the planet. Now, Minecraft servers do not inherently accept HTTP requests. They operate on a different protocol called TCP/UDP.
Yeah.
But we don't have to worry about any of that, because our plugin is written in Java. And Java has some built-in tools that allow us to receive and respond to HTTP requests.
Okay.
I put together a little website where you can make a to-do list. After playing around a little bit, I was successfully able to read, write, update, and delete data all from this website. All this website does is send requests to the server. So we don't even have to have the game running at all. So, success, right? I've won. I mean, that was the whole goal, right? It was a database, and we have a database.
Well, I'll see you won.
No. You see, this is where things get out of hand. You see, I still have this one idea I just can't get off my mind. What if we could do more? What if we could conquer the impossible?
This is like
what if our destiny
an advertisement for getting a job.
I mean, we're already storing bytes, and bytes are the foundation of all computing. So
work with Prime bytes, Company.
Can we store images? How about audio? Can we do video? The answer is yes, yes, and hell yes. Oh yes, this is what I've been waiting for. This is my crowning achievement. It's everything I've ever wanted.
Brother.
It is manifest destiny. This, ladies and gentlemen, is the S3 bucket.
Wait, bucket. I remember working with bucket.
Yes, I'm very proud of that.
This is like a Michael Reeves video, but in Minecraft.
Alright, straighten up, we got a lot to do. Now, if we're going to be storing entire files, we got to make some changes around here. Firstly, I think we need to find a more efficient way to store bytes. Right now, we're using binary, meaning we're only using zeros and ones. However, I want to switch over to using hexadecimal instead. That term sounds scary, but it's pretty much the same thing as binary with more flexibility. You see, instead of being limited to zeros and ones, hexadecimal will give us a total of 16 characters to work with. Those are the numbers 0 through 9 and the letters A through F. And as if it's meant for this very purpose, there are exactly 16 wool blocks in Minecraft.
Oh my god.
Because we now have a wider range of characters to use for each block, we can now store an entire byte using only 2 blocks instead of 8. Because each byte now only needs 2 blocks, we can do the exact same thing as before, except we'll only need a quarter of the space.
Bruh.
We probably should have been doing this to begin with, but I wasn't too worried about efficiency when we were just storing text. We also need to take care of our size problem. I'm short, yes, but that's not what I'm talking about. You see, right now, if we try to store an entire file with just one chunk, we're going to be pretty limited. As we mentioned before, each chunk is 16 blocks wide and 16 blocks long. As of Minecraft big, version 1.18, our vertical space is limited to 384 blocks. That is, the space between y equals -64 and y equals 320. If we do the math, we find that each chunk can hold a maximum of 98,304 blocks.
Making us do math, bro.
And since each byte is going to take 2 blocks, that means we can hold a maximum of 49,152 bytes per chunk. That's about 49 kilobytes. That would be impressive in the 1950s, but nowadays, that's nowhere near enough to store anything important. To fix this, I want to set some rules about how exactly we're storing data. Remember that chunk at 0, 0? I am now declaring this chunk to be the God chunk. It will not hold any data, and it will now serve as a reference point for all of the other chunks in the world. From now on, everything to the north of the God chunk will be reserved for file storage, and everything to the south will be reserved for the database. When we upload a file, we can find the next available chunk directly north of the God chunk and assign that chunk to be the new file's home.
Bro.
The home chunk will hold information about the file, like
its
its title
the code,
and its type.
Bro, I want to see the code.
We will then move to the first chunk directly east of the home chunk and start writing the actual bytes that make up the file. When that chunk runs out of space, we can move east again and continue. Theoretically, this will allow us to write files that are infinitely large.
Bro.
We can call this block allocation live logistics system. I decided to first start working on image storage and then move on to other file types down the road.
You can see his source. You can see his source code on his GitHub. Oh my god! Wait, bro. Oh my god. I'm gonna be real. This is the world file. I want to see the query. I'm gonna have to chat. That's too much work, Brian.
Gallery and uploaded pictures of cats that I found on Reddit. We've got Lucky Cat, we got Sleepy Cat, and we've got Freaky Cat.
What?
Nevertheless, we now have the foundation for a file storage system. So we can just
I was not ready for Freaky Cat
with all file types, right? Unfortunately, not exactly. You see, right now, when we upload an image to our gallery, we're able to store that image's bytes in their most pure, untouched form. Just as God intended. Which, I know, it's beautiful, but get that out of your hand, we got work to do. The only reason that we can get away with this is because I've specifically set up the gallery to only accept JPEG images. So we already know what type of file we're working with off rip. We can use this system to upload any type of file we want, but we won't be able to put that file to work later down the road. You see, when our website requests to view a file from the server can't just respond with a collection of bytes. The browser won't be able to understand what it's looking at. Depending on the browser, it may successfully figure it out on its own, but it's possible that the browser will tweak out and start speaking enchantment table.
Oh, great.
When responding, the server has to tell the client what type of file it's responding with. This is where those headers from earlier will come in handy. We can add a content type header to the response, telling the client what to expect. Right now, our website can see the images that we've uploaded because I've specifically set the content type header to be JPEG image. But if we want to be able to upload any type of file, we need to be able to set this header dynamically. Now, we could just continue uploading raw bytes and then have the server figure out what type of file it is by looking at the byte structure.
This is insane.
But the problem is that every type of file has its own unique byte structure. I would have to write a parser for every single file type that exists. And, no.
Yeah.
That's why we're going to encode all files to base 64 instead. Remember when we talked about binary and hexadecimal?
Bro.
Well, you can think of these systems as being base 2 and base 16. Base 64 extends that logic to the extreme, giving us a total of 64 characters to work with. It is comprised of the numbers 0 through 9, lowercase a through z, uppercase a through z, as well as the plus symbol and the / symbol. Encoding a file to base 64 will convert a file's raw bytes into a long string of numbers, letters, and symbols. We can easily encode the file on the client side before sending it off to the server. And the benefit here is that because the string is made up of simple, common characters, we can now send the file as part of a JSON object. And since we now have complete control over how the upload request looks, we can just grab the file's type and title from the client side and attach it to the JSON object. Then, the client will send that complete object off to the server. Now, instead of having to parse the file's raw byte structure, all the server has to do is grab the file's type and title from the JSON object. And
I do IT, but I have no clue how you could do this.
That information to the chosen home chunk. This will ensure that the server has everything it needs to properly serve that file ahead of time. I'll put together a proper S3 bucket portal that accepts all file types and then shows a link to the file once it's been uploaded. And this works way better than I expected. However, I did have some issues trying to upload video files. Their sheer size is just too much for the server.
So this is the guy that when I get a job and I'm at the interview and I don't get chosen, this is the motherfucker they choose, as they should. This is the guy that shows up and becomes my competition.
To handle. Sometimes the server will crash, sometimes it'll stop responding, and then sometimes my computer will go into kernel panic and corrupt all of the footage that I've recorded for the last few hours. But after taking my computer over to Unit 731 for a few hours, I was able to find that our upper limit for file sizes is going to be about 5 megabytes. 5 megabytes is not great, but it's good enough to store Vine, which is good enough for me. Now, 5 megabytes is still massive on our scale. Remember how we were trying to avoid disturbing nearby villages? Well, not anymore. Get conquered, idiot. We're building the future over here. And with that, I thought I was finally done. But then I stupidly got curious and threw an HTML file at it. And even though it's exactly what I expected, I was still pretty delighted to see a web page render out just fine with no additional intervention. So at this point, I hate myself for this, but I think I've got an idea. God help me.
Bro.
Alright, so for the website, we could just build a newer, shinier version of the cat gallery website we were working on, but that seems a bit underwhelming to me. It doesn't feel like the best use of what we built so far. So instead, I had the idea for a social media platform where Minecraft players can upload images and videos of their latest creations. We can call it MC Social, because I'm really good at names. And I knew that building the interface for MC Social was going to be a monumental task, so I got to work right away. And by got to work, I mean I went to Claude and had it do the work for me.
Okay.
I used AI to generate the HTML and the CSS. All the logic, all the JavaScript is still going to be hand-rolled. And don't act like you haven't seen my design skills. I'm terrible. I should not be allowed to use CSS.
Oh, hell no, man.
And to be honest, this is not the worst AI slap I've ever seen. I mean, it's obviously AI generated with all the emojis and whatnot, but it's light years ahead of anything that I was going to do. Now, if we're going to turn this slop into something we can actually use, we do need to make some upgrades to our database. It kind of took a backseat when we started working on the S3 bucket, but now we're back in action. See, one of the biggest problems we have right now is we don't have a way to categorize our data. Whenever we add something new to the database, it gets added to the same long list as everything else. That was fine when we were doing a to-do list because everything was the same. They were all JSON objects that had a title and a description, nothing else. But for a social media platform, we're going to have more complex data than that. We're going to have posts, we're going to have users, we're going to have profiles, we're going to have a lot more to deal with. A typical database will organize data into tables. Think of these like the data tables you would see on a spreadsheet. You might have a table to track your expenses, where each expense has two fields, a title and an amount. You might have another table that shows your bills, where each bill has three fields, a title, an amount, and a due date. For our table system, we can pull out our block allocation live logistics system.
Balls.
You remember how our file storage works?
I didn't even notice that, brother.
Block allocation live logistics system. You remember how our file storage works by finding a home chunk to store a file's metadata? We can do the same thing on our database side to create tables. We'll find the next available chunk, now south of the God chunk, and then write our table's title there. Then, every data entry under that table will go to the east of the home chunk. But now we have a problem. Previously, we've been adding to the database by sending a put request to an endpoint. An endpoint is like a variation of the server's URL. So if we were hosting the server from MCDB.com, we would previously have sent a put request to MCDB.com/add-data. And because I'm a caveman, I set up an endpoint for every single function the server has. Now that we're organizing our data into tables, we need to find a smarter way to send complicated requests to the server. That's why I'm going to condense all of our endpoints into one single endpoint, and then we'll start sending commands to that endpoint.
Okay.
This will be similar to how Minecraft's command system works. For example, if you wanted to set your game mode to be creative, you would execute the game mode creative command. Or if you wanted to set the time to midday, you would execute the time set day command. In our system, if we want to create a new table called posts, we would execute the create table post command.
Yeah,
Later,
that's
if the website wants to
normal.
see all the data from that table, it would execute the select all from posts command.
Okay, see, this I
Command system
recognize.
is called a query language. And if these commands look familiar, it's because I've modeled them to look and feel like the world's first query language, SQL. Now, even though MC Social will live and die on my hard drive, we shouldn't operate on a trust me bro protocol. Now, I admit the caveman inside my head really wants to ignore security altogether and just move on. But we've already done so much over-engineering that it feels kind of wrong to stop now. A good security system begins with authentication, which is simply the ability to register new users and sign existing users in. Now, to save time, I'm not going to get into proper password storage in this video. But if you are interested, I'm going to link a computer file video where Mr. Tom Scott explains the topic perfectly. If you're already familiar, just know that we are indeed hashing and salting passwords. No plain text around here. I do, however, want to discuss what happens after a user gets signed in.
Oh my God.
Let's say you want to sign into your account. You begin by going to the login page and typing in your username and your password. If you put in the wrong username and password, the server will respond with a thumbs down. Makes sense. But what happens if you put in the correct information? You see, a simple thumbs up is not enough to actually keep you signed into the website. In this situation, the server will typically generate and respond with a token. A token is kind of like a receipt. It serves as proof that you successfully provided the correct username and password.
System,
At its core, at least in our case, a token is a long, randomized string of letters, numbers, and symbols. It is unique to both your account and your device. When the website receives a token, it will be saved to your browser. And when the website sees that you have a token saved, that's when it will know that you are indeed signed in, and it should act accordingly. For example, with MC Social, if you are not signed into an account, you will see a login button and a register button at the top right. But once you are signed in, those two buttons are replaced with a profile button and a log out button. Using tokens will also unlock a slew of possible security features. Specifically, we can now set up a system of data ownership. Let me explain what I mean. Let's say you create a post that you're really proud of. And because this post belongs to you, you'll see a shiny delete button underneath it. If you notice, you don't see a delete button under any other post that doesn't belong to you, which makes sense. You shouldn't be able to delete somebody else's post. But that's when I show up. And I'm a bad guy. I log into my account and I create a post of my own, which gives me access to my own delete button. If I right-click this button and click Inspect Element, I suddenly have control over what this button does. Currently, the button requests to delete post number 9, which is my post. But if I change this 9 to an 8, I can now request to delete your post instead. If we don't have any safeguards in place, this request will go through. That's where tokens come to save the day. We can set up the server to require that all delete requests include a token as a header. Now, if the server receives a request to delete a post without a token, the request is immediately denied. If a token is included, the server will first verify that the token belongs to the same user who created the post.
Bro, this is hurting my
the token
brain.
serves as proof that you are who you say you are. So if the token belongs to the same user who created the post, the server knows that it is safe to delete that post. This is known as data level security, which means our data is protected by its own properties. And with that, I think we're finally done. In a world where Minecraft is more than just a game. No, I'm not doing that again. What I will say is, look at it. Look at that. That's awesome. It's amazing. Is it practical? No. Is it useful? No. Would I give this to my kid? Absolutely not. But is it cool? Hell yeah, it is. But I think it's time to answer the biggest question of all, which is, Noah, what the hell? Why does this exist? Have you ever touched grass before? And I'll have you know I have touched grass before. It was terrifying, so I went inside immediately and washed it off with G Fuel, but I did it. But in all seriousness, I actually learned a lot from this project. Whenever I work on a new website or a new app, I tend to offhand all my back-end logic to a service like Supabase. A lot of the things that I did for this project, like data level security for example, I've never actually done that by myself. I've always understood how it works at a conceptual level, like I can explain it to you, but now that I've actually built my own solution, I am more familiar with the services I've been using for years. But I would actually argue that the best thing that I learned is what to learn next. You see, you don't know what you don't know until you don't know it, if that makes sense. For example, with data level security, I've never done that myself, so I kind of just winged it. Now, I'm pretty sure what I built is functional, works well, and is secure, but is there something that I'm missing that I would have been able to point out with years of experience? Maybe after I'm done with this video, it might be a good idea for me to go read up on data security a little bit more, see how other people handled it. Because that's what it's all about. We need to learn more every single day. A lot of programmers make the mistake of working on the same thing over and over and over again. I made this mistake in the worst way possible. I started programming 13 years ago. And for almost that entire time, I built video games and desktop applications. Now those skills have value on their own, of course, but I found that I was just building better and better versions of the same thing over and over and over again for years. I never branched out into different technologies and learned about the different areas of computer science. And now that I'm entering into college, I wish I could take that time back, because I'm recognizing how further ahead I could have been if I had been more focused on branching out for the last 13 years. So for any other programmers who are watching this, I implore you, please don't make the same mistake that I did. You will be so mad at yourself. A wise man once said,
"Stop looking at learning as a 6-month, 1-year, 2-year, 4-year exercise, but as a 20-year, 30-year exercise."
If we can learn more every day, become better programmers, or become better at whatever field you're in or whatever hobby you're into, well then we're unstoppable. And if I keep it up, keep branching out into more things and learning more about my field, well then maybe one day, I will understand CSS. Well, that's all I've got for you. If you made it here, you're a real one. Thank you. Deuces.
Wow. That was a great video. That was a great video. And I think that ending really... Wow. That whole part of him talking about doing the same thing over and over again. It's kind of what I've been doing with gaming content, if you think about it. Wow, that's an amazing video, chat. If anyone was wondering, I'm gonna send the link in chat. The link's in chat right now. Go show it some love, man. Oh my god. Because here's the thing, right? I think the same goes for me with content creation. I've been working on just Valorant content. I wished I would branch out earlier and do other stuff. And I think that's insane. That's really cool. Wow. I'm actually lost for words because that was really good. I think it was a goofy project. So it kind of didn't entice me completely. But that was great, man. Oh, what the fuck? It's still talking. That was great. Wow. Wow, we did a lot today, chat. Today we played Valorant. Actually, no, we started with Spider-Man. We then played Clash Royale. And then Valorant first, and then Clash Royale. We did Valorant custom, so it felt like a new game as well. And we did React content. Some would say it's the full gauntlet. Bah! The Thanos gauntlet. That was a cool thing today. Ladies and gentlemen, it's been an amazing stream. I'm gonna go, oh wait, that's the wrong. I'm gonna go raid holes real quick. Actually, can I raid someone else? Let me see. Yeah, I'm gonna go raid It's Kiri, chat. If anyone's wondering, that's one of my boys as well. I met him at TwitchCon. And talked to him multiple times before. He's just an amazing guy. If anyone wants to show love to him, he's currently playing Hollow Knight Silk Song, and I think you guys would enjoy his stuff. Hey, everyone, have a good one. Enjoy everything, and see you guys next time. Goodbye. I'm going to be live tomorrow. Probably same time-ish, maybe earlier.